Hey guys, Mr. Wiegand. Today we're going to look at angle relationships caused by two lines being intersected or cut by a transversal. So when we're looking at this picture here, we have our two lines and it's being intersected by this other line which we call the transversal line. Alright, when we have the situation where a transversal goes through or intersects or cuts two other lines or more lines, but we're dealing with two lines, we end up getting 8 angles. So we're looking at 1, 2, 3, 4, 5, 6, 7, those 8 angles right there. These angles are going to have certain names to go with the relationships that they have with other angles. We're going to start off with interior and exterior angles. So interior angles, if you think of the word interior, it would mean inside. If you're going to paint your house and you're going to paint your living room, that's inside your house, so you would get interior paint. So when we say interior or inside, we're talking about inside the two lines. So we're looking at angles 3, 4, 5, and 6 because they're inside these two lines. Okay, so our interior angles are angle 3, angle 4, angle 5, and angle 6. If we're talking about exterior angles, we're talking about outside. Interior, inside, exterior, outside. So here, we're talking about outside of those two lines. So we're looking at angle 1, angle 2, angle 7, and angle 8. Angle 1, angle 2, angle 7, and angle 8. All right, so there's 8 angles. 4 of them are interior angles. 4 of them are exterior angles. All right. We have our next term, alternate interior angles. Now, some people can just kind of look at those and use a little common sense and logic and figure out what angles we're talking about. So let's think about it. First off, interior we already talked about. In this picture, angles 3, 4, 5, and 6 are interior. Now, what's alternate mean? Imagine you're walking down a street and you and your friend are on alternate sides of the road. Well, that would mean you were on one side and your friend was on the other side. So if this transversal right here is the road, alternate would mean one of you is on this side and one of you is on this side. All right, so now let's take a look. Alternate interior, that would be angle 3 and angle 6. They would be alternate interior angles. It's a pair because they're both interior angles and they're on different sides of the transversal. So angle 3 and angle 6 are alternate interior angles. Okay, they're not the only ones though. We also have angle 4 and angle 5. They're both interior and they're on alternate sides of the transversal. So angle 4 and angle 5. So we get 2 pairs of alternate interior angles. All right, next is alternate exterior angles. All right, same idea, exterior, they're the angles that are on the outside. That's angle 1, angle 2, angle 7, and angle 8. Alternate on different sides of the transversal. So I'm looking here, I see angle 2 and angle 7. They're both exterior and they're on different sides of the transversal. Angle 2 and angle 7. And then I also see angle 1 and angle 8. Angle 1 and angle 8. They're also exterior and they're on alternate sides of that transversal. Okay, this is going to seem a little weird at first, but you get used to these terms pretty quick. And like I said, if you really break down the terms, they kind of make sense. All right, corresponding angles. Here's what we got to think back when we did similar figures and we talked about corresponding parts. Corresponding parts meant parts that were in the same position. Well, same idea here. If I'm looking at angle 2, it's to the left of the transversal and above it. Okay, so if I look down here at these 4 angles, which angle is to the left of the transversal and above line B? Well, that's 5. So angle 2 and angle 5 are corresponding. Okay, how about angle 3? What angle down here is to the left of the transversal and below the line? That would be 8. So angle 3 and angle 8. All right, now we have angle 1. What's in the same position as angle 1? To the right of the transversal, but above the line, that's angle 6. And then lastly, we have angle 4 and angle 7. They're both to the right of the transversal, and they're both below the line. Angle 4 and angle 7. All right, so that's corresponding. You get 4 different pairs there. All right, now we have same side interior. All right, same side interior. We know what interior means. That would be angles 3, 4, 5, and 6. Same side. If alternate means on different sides of the transversal, same side means on the same side. So angles 3 and angle 5. They're both on the left side of the transversal, and they're both interior. So angle 3 and angle 5 are same side interior. And then angle 4 and angle 6. They're both on the right side of the transversal, and they're both interior. All right, same side interior, you get 2 pairs. All right, now we have vertical angles. Vertical angles, I like to think of as they're the angles that are across from each other. So if I'm looking at angle 2, if I go directly across, it takes me to angle 4. They're vertical. If I look at angle 1, I go directly across, that's angle 3. If I come down here, angle 5 is across from angle 7. And then, of course, angle 6 and angle 8 are vertical. They're across from each other. Okay, now, another way that I like to think of this is, if you go like, that was ugly. If you go like this, and like this, you make 2 V's pointing at each other. So when the 2 V's are pointing at each other, it's those angles that are across from each other, V for vertical. That helps some people. Same thing here. Here's the V, pointing at this V, so 6 and 8 are vertical. Okay, another way to think of it. All right, now we're going to talk about parallel lines cut by a transversal. You're going to see something like this. All right, line L, and it has this symbol, and then line M, and that symbol means parallel, okay, because it looks like 2 parallel lines. So here it's telling us in this picture these 2 lines are parallel to each other. When the 2 lines that the transversal intersects are parallel, that causes something even more special to happen than the angle relationships that we saw before. When we have 2 lines and they're cut by a transversal and those 2 lines are parallel, alternate interior and alternate exterior angles are congruent. Meaning, angle 1 is the same as angle 8. If angle 1, let's say, was 70 degrees, angle 8 is 70 degrees. Angle 7 and angle 2 are congruent. If angle 7, let's say, was 100 degrees, angle 2 would be 100 degrees. And then same thing with alternate interior. Angles 3 and angle 6 would be the same. And let's go green. Angle 5 and angle 4 would be the same. And that's special. You know, if I know one of the angles, I can know the other angle because I know that alternate interior angles are congruent and alternate exterior angles are congruent. Corresponding angles. Well, it turns out that when a transversal intersects 2 parallel lines, corresponding angles are also congruent. So angle 1 and angle 5 are the same. They're congruent. 3 and 7 are congruent. Angle 2 and angle 6 are congruent. Angle 4 and angle 8 are congruent. Okay, corresponding angles when you have parallel lines are congruent. Vertical angles, guess what? Congruent. So we have angles 1 and angle 4 are congruent. They'd be the same. 2 and 3 are congruent. 6 and 7 are congruent. 5 and 8 are congruent. So if you know one of them, you know the other. We also have same side interior angles. Now, it's a little different. So, like, let's say 3 and 5 are same side interior. If I look at them, I can even tell that they're not congruent. Angle 5 is, less than 90 degrees. And angle 3 is definitely greater than 90 degrees. Angle 5 is acute, angle 3 is obtuse. Turns out that they are supplementary. And we all know that supplementary means they add up to 180 degrees. So if I knew that angle 3 was 120 degrees, angle 5 would be 60 degrees because they have to add up to 180. And the same thing here for angles 4 and angle 6. They're supplementary. So same side interior angles are supplementary. Now it turns out they're not the only angles in here that are supplementary. Also turns out that angles that are next to each other or adjacent are supplementary. Angles 1 and angle 2 are supplementary because look, they're on a straight line. And we know a straight angle is 180. Same thing with angle 2 and angle 4. They're supplementary because they're on a straight line. They're next to each other. So there's more than just same side interior angles that are supplementary. There's other pairs. All right, now, what we can do with all this, we can solve for some of the missing angles. All I need to know out of all 8 of these angles is the measure of 1. So they're telling me here that the measure of angle 1 is 75 degrees. So angle 1 is 75. I can find all the other angle measurements based on the relationships that we just looked at. So let's look. Angle 2. That's this angle right here. Well, angle 1 and angle 2 are next to each other. They're on a straight line, so they're supplementary. So they have to add up to 180. So if angle 1 is 75, angle 2 must be 105 degrees. Angle 3 is right here. Well, I could think of these two are supplementary. They're next to each other. They're on a straight line, so they must be supplementary. Or angle 2 and angle 3 are vertical, and we said that vertical angles are congruent. So if 2 is 105, 3 is 105 also. There's a couple ways I could have figured that one out. Angle 4. Well, once again, a few different ways. 3 and 4 are on a straight line, so they're supplementary. 2 and 4 are supplementary. Or 1 and 4 are across from each other are vertical. Vertical angles are congruent. So if 1 is 75, 4 is also 75. And I could have got that 75 degrees 3 different ways there. All right, now we're looking at angle 5. All right, well, angle 5 and angle 1 are corresponding. Corresponding angles are congruent. So if 1 is 75, 5 is 75. I could have looked at 5 and 4 are alternate interior. Alternate interior are congruent. So if 4 is 75, 5 is 75. I could have looked at, 3 and 5 are same side interior, and they're supplementary. So if 3 is 105, 5 must be 75. They have to add to 180. So a bunch of different ways you can do it. You only need to figure it out one way, though. I come down here to angle 6. A bunch of different ways. I'm just going to look at angle 3 and 6. There's alternate interior. 3 is 105, so 6 is 105 because alternate interior angles are congruent. 7, how about 3 and 7 are corresponding? Corresponding angles are congruent. So angle 3 was what, 105, so angle 7 is 105. And then last, angle 8, I don't know, maybe angle 1 and angle 8 are alternate exterior. Alternate exterior are congruent. So if 1 is 75, 8 is 75. And then if you look over here, you'll notice that there are 1, 2, 3, 4 angles that are 75 degrees, 4 angles that are 105 degrees. So that should always work out that way. You should have 4 angles that are one number, 4 angles that are another, unless all 8 are right angles and they're all 90. That works out sometimes too. Now the one thing missing here is we were talking about parallel lines before, and I showed you this. Line L is parallel to line M. The only way I can do these problems is if those lines are parallel. And I was assuming they were parallel based on our previous example, but you really should see a statement saying that they're parallel or a symbol that's showing you that. You need to know that they're parallel to be able to do all this. Otherwise, they just have the relationships of alternate interior, alternate exterior, but you can't say that they're congruent or supplementary. That only is true when line L and M are parallel. All right, we have lines intersected by a transversal and all the different angle relationships caused by that, and then something special when the lines are parallel. All right, good luck with all that, guys. It's a little tricky at first, but once you do a few of these, you get used to it, and this turns out to be a pretty good section for most of you guys. Good luck.